Hey everyone, welcome. In today's tutorial, we are going to dive deep into C# reflection in Unity. First of all, let's start with the basic definition of reflection and what it is. So we can think of reflection as the ability that gives your program to reflect on itself. With that, we can basically inspect and manipulate types, methods, properties, and other codes. Now, I have created a simple script called basic reflection. Currently, it's empty. So let me quickly write the code, and along with that I'll explain the basics of reflection. So the reflection is part of the using system.reflection class, system.reflection package, sorry. And in order to explain it, I'll create another class over here, a simple public class called player. This is a normal C# class, and we are going to create properties. So okay, here I have quickly created the class. It's a player class with two public properties, name and health, and two functions. One is for taking damage and one is for regenerating our health. And now let's create the script or the code that will inspect this class. So let's do that. So and I'm going to do this here in my mono behavior basic reflection class, and we are going to do that in our update function. And we are going to say if input.get mouse button down 0, if we click on the mouse button, we should see the details of our inspection. So how do we inspect the class? First of all, we need to know the type of this class. So we will say type t is equal to type of which class? The player class. This will give us the type of this class, whatever its type is basically. And from the type we can log the information. The first one is going to be debug.log. They are going to log the class name, and after that we can log some public properties. Let's do that. So we will say that debug.log some public properties. Let's quickly write it, public properties. And here we are going to for each loop, because we can have more than one public property. And we are going to say for each variable property in t.get properties, and here we are going to say that debug.log, and we are going to log a lot of information. So the first one is going to be my property name, the next one is going to be the type, and after that we are going to log the can read. So this is going to be can read and can write. So these are the properties or the details we are going to debug to the console. And also apart from that, we also have some methods over here. So let's quickly write the code to debug them as well to the console. Okay, here's the code to basically debug the method names into the console. And here I have set that t.binding flags public. It means that we will basically get all the public methods or the non-public methods, and we also get all the instances, and we will skip those methods which are auto-generated by C# or by Unity. So let's do that. And we also are going to basically log the access modifiers. So this is the very basic example of reflection. We have a public player class, we have some information in it, and then using reflection we basically log all the information about that class. So let's quickly run this. Going back to Unity, I am going to attach this script to a game object. So let's create a new game object. Let's attach our basic reflection script to it. Click the play button and let's go to our console. So we need to attach our console here. I think it's in the Windows General console here. Let's attach it over here, the scene view. And if I click, I can see all the information. The class name is player. It has public properties. The properties are can read, can write. We can read and write both of them. This is the name health is the second property. We have the methods take damage, regenerate, and boolean equals. So this boolean equals is basically generated. It's a method that is available in each object. And reflection basically helped us reflect upon this class and then make a decision based on what we discovered using reflection. It's like having an X-ray vision into your own application. Now this was a very simple and basic example in order to explain what reflection is. Now let's talk about when to use reflection. So we are going to look at 3 scenarios, but you can look at others as well, and all of these will be related to Unity. So the first scenario is editor tools and custom inspectors. So this is one of my favorite use cases for reflection. It's basically to enhance the Unity editor experience. Here's a really simple example. So let's quickly create it. Okay, let's create an editor folder since this is going to be an editor script. So editor, and inside this folder we are going to create our script, which is going to be called, let's first create it, where is scripting, mono behavior script, and this is going to be called our component explorer. Open this up. Now since this is going to be an editor script, we are going to say editor, and we are going to remove this pre-generated code and import the unity.editor class, and we are going to say this is a custom editor. It is going to be acting upon each and every mono behavior script, and it will also be able to edit child classes. Now the first thing we need to do is override our own inspector GUI class called the draw default inspector. This will basically draw the default inspector first, and then we are going to add our own custom section. This is going to be let's give it some space first, then let's add an label field dot label field, and this is going to be called custom explorer. And after that, what we are going to do is we are going to get the mono behavior component from the target, and we don't need this, we can directly do this. And let's import the system.reflection over here, using system.reflection, and this is going to be mono behavior. After we get the mono behavior type, sorry, the mono behavior, we need to get its type, and the type is going to be really simple. Type equals the component type, and let's import this type. Import type, we need it from the system.type, and after we get the type, this type is the script, basically a mono behavior is a script, so we get the type of that script, and we will now show the info of the fields, basically the private fields that have a serialized attribute. So let's do that. Field info, do this. So this is going to be the component type, which we got the type of the script. We are going to get the fields of the type instance fields, static fields, public, basically all the fields we are going to get them. And after getting all the fields, what we are going to do is in that specific mono behavior script, for each field in the fields array, we are going to say that if the field dot get custom attributes, and if it's a serialized field, if it has a serialized field basically, then what we are going to do is we are going to say editor.gui layout, we are going to create a label field. Let's give it a proper name. This is going to be a hidden field, and the field name is going to be field name. Also, let's add a value for this. So this is going to be a value field, and it is going to say get the value of the script, basically the mono behavior script, and we don't need toString over here, this is useless. And this will basically give us all the fields when we hover our mouse over the mono behavior script in the editor. And finally, let's show the method count. So we're going to say method info, and the number of methods, basically get all of them. And after getting those all the info, we are going to say editor.gui layout dot label field the count of those methods. Method count, and this is an array, so we are going to use methods.length. So this is a very basic use case and a very powerful use case of reflection, that is to enhance any mono behavior component by showing its hidden serialized fields and method count, basically all the fields, but here we only show the serialized fields. And if we save this, go back to Unity, and since this is a mono behavior, here I can see that it has a basically a method count of 102 because it's showing all the methods, and it should also show the serialized fields. But if you go over here, there are no serialized fields. Let's create some serialized fields. So if I create a serialized field, and let's create another serialized field in our mono behavior script over here, let's call this basic reflection serialized field. Let's save this. Let's go back to Unity, and after the script has been saved, you can see that we can see serialized field over here. So this is a very powerful use case of reflection. Now let's look at another use case, which is called plugin systems. In this is basically useful for building flexible plugin architectures. Let me show you how to create a really simple plugin system. Okay, so let's get started with the plugin systems. First of all, what we are going to do is we are going to create the script for our plugin system. So let's do that. Create a scripting and a mono behavior script. Let's call this our plugin manager. Open it up, and inside the script what we need is, first of all, let's remove this, and we are going to need an interface. Let's quickly create one here, and this is going to be the interface for our plugin, iGame plugin. And let's give it some basic things that we need to implement: an initialize method, void initialize, and then an update, void update. So these are the methods we need, and we are going to have a list of plugins here. So this is going to be a private iGame plugin. This is going to be from the system.collections namespace, and this is going to be our loaded plugins. And in the start method, what we are going to do is we are going to load the plugins from the assembly. So load plugin, and we are going to pass the assembly.getExecutable assembly. Okay, now we need to create this method. So let's quickly create the load from assembly method, and currently we don't need to implement anything in it. We'll do this later on. And then after we have loaded the assemblies, we will for each over all of them. So for each assembly in the loaded plugins, so plugin, we are going to debug the name of the plugin basically, and we are going to initialize it as well. Now let's finish the update and the load plugin from assembly functions. So in the update, what we are going to do is really simple. We are simply going to call the update function of the plugin. We are going to say plugin.update, and in the load assembly we are going to load the actual types using reflection and load the actual plugins and create their instances. So first of all, let's get the type. So we have many types, and we are going to get the types from the assembly, which is our get executable assembly. And then we are going to for each over this, for each over the types, and if the type is an abstract type or if it's an interface, skip it, we don't need anything. So if the type is abstract, or if the type is an interface, type dot interface, then don't do anything and just skip it. We say continue, and then inside the for loop we will check the type and if it implements the iGame plugin. So if the type of our assembly, remove this type dot of iGame plugin is assignable from the type, which means that it implements the iGame plugin interface, then we will try to load this. And loading is really easy. All we need to do is say that iGame plugin, and we are going to basically activate its create its instance using the activator class, and this activator class is also part of the namespace system, and through this we can create different instances. So once we create the instance, we would simply add this plugin to the loaded plugins and debug a message that we have added this plugin, or basically loaded this plugin. So let's load it plugin, and that's it. And after that, let's create an example plugin which will implement our iGame plugin. So for the sake of simplicity, let's do it in this script file. So let's see, where does this end? Let me close this. Okay, so let's create the class here. So this is going to be a public class. Let's call this example plugin, iGame plugin. And now, since we implement the iGame plugin, let's implement its members. So in the initialize, we are going to debug a message. In the update, we won't do anything, and in the public string, we are going to give it a name, and this name is going to be let's call it example plugin. In the initialize, simply debug a message, plugin has been initialized. Now the beauty of this system is we can add as many plugins as we want to, and the plugin manager will automatically use them without modifying any existing code. So now let's assign this plugin manager to an object in the hierarchy. So let's assign it to this game object, this plugin manager. Okay, let's, and this is also showing the details from our custom explorer which we created inside the basic reflection class. So let's run. So it says loaded plugin, example plugin, initialize example plugin. So if you go back to the script, we have successfully loaded this plugin, and if we add other plugins, they will be loaded as well, and you can add your functionalities inside these plugins. So now the third use case, which is often used, is basically dynamic component management in larger projects, not in smaller projects, but I'll give you an example of this as well. So let's get started with this. So for this, first of all, what we need to do is create our script, and we are going to call this our component manager. Open it up, and inside this component manager, first let's remove this, and inside over here we are going to create our first function, which is going to initialize all components basically, and this will auto find and call initialization methods on all components. So let's do that. Public void initialize all components. Okay, now the first thing we need to do inside this function is get all the components. So component array all components, and get components, not resources.find, basically get components. Now this will get all the components, and we are going to for each over these. So the first component is basically this component on all components, and the first thing we need to do is get the type using, if this is part of the using system, this is going to be a component type, and we are going to get the type of the component. Then we are going to get the method info, and we are going to look for initialize methods regardless of its parameters. So how we can do that is easy. We already know about method info, which is part of the system.reflection, and inside, since we are going to call the initialize function, we will say init method equals to component type. Okay, this is good, component type dot get method, and the method name is going to be initialize. This name and the method name should match, and since we want to call the initialize method regardless of its components, we need to add one more binding flag, which is going to be non-public as well, meaning we need to call a public and non-public. And then if the initialize method is not null, we'll get its parameters. So if the init method is not null, we will try to get its methods parameters. We already know how to get that. It's part of the parameter info, parameters, and get parameters. And if the length is equal to 0, if parameters dot length equals to 0, then what we are going to do is we are going to debug a message, debug.log initialize, and then we are going to say component.name. Okay, sounds good. And finally, once we have the method, we need to invoke it using the component, and the second parameter is basically our parameters, and we don't have any parameters now since the length is 0. Else, if we have parameters, we are going to skip it, skipping component type.name because it requires params. And after this will call the initialize method on every component attached to a game object without needing to know in advance what components are there. Super useful for modular systems. And now let's test this out. So I need to attach this to a script, and let's attach it to our game object. This also shows the method count because of our basic reflection, in which we have the custom explorer. And one thing I think I missed, let's first test it out, is this didn't work because we didn't call this function, the initialize all components, anywhere. So let's call this first of all. So let's do it inside the start function, initialize all components. Or we can, since it's a public, we can get this component and call it there, but for now let's call it in the start and see the result, and then I'll show you how to call it from another script. Since we don't have an initialize method, that's why we don't see anything over here. So let me show you how to call it from another function now. This is the component manager, and let me create an example script which has the method of the name initialize. So let's create a script. Let's call this example script. Open it up. Let's quickly add the initialize function. Private void initialize. Do remember the name should match exactly with the one inside the component manager. So let me copy this and paste it here, and this is going to say debug.log, and we are going to say examples script initialized. And now let's call this component manager. We are going to call this here in the start method of the example script. Let's call the component manager here in the start. So for the sake of simplicity, I'll just create a public component manager, and simply say component manager dot initialize all components and hit the save button. I haven't explicitly called this initialize method anywhere. So for in an example script, let's attach the component manager to it. Here, where is the example script? Let's attach the component manager, and let's hit the the play button. And here you can see we have successfully called the initialize example plugin without explicitly calling it anywhere. So any component that has the initialize function, whether it's public, private, or anything, we can call it. So these were the 3 use cases of reflection that I commonly use, but there might be other use cases as well. While reflection is powerful, it has some drawbacks and performance considerations as well. You need to keep those in mind. One drawback is its type safety issues, is that reflection basically bypasses the type safety mechanism. It means that an error that would normally be caught at runtime, compile time, will be caught at runtime. And as you can see, we have no respect for the access modifiers. We can call public, private, any methods we want to. So it basically depends upon our use cases and when we need them. They are a powerful tool, but they need to be used with care. So I hope you guys enjoyed this video, and I'll see you in the next one.